Okay, let's start with the 4.3. Last week, when we talked about 4.2, we talked about how to solve the system of linear equations by substitution method, right? So today we're going to talk about another method called addition method. This method will also help us to solve the system of linear equations. So first, let's check why we could use the addition method, because this method is based on this property of equality. So if we know A is equal to B, so we have this equation, right? Then we have another equation. If C is equal to D, by using the property of equality, we will get this conclusion. A plus C equals B plus D. So you can treat left side plus left side, right side plus right side. The equation remains equal, remains true. Okay? Left side plus left side, right side plus right side. It's still an equation. So let's check some example to help you understand why we could use addition method. So first example, it's an easy example. So when we try to solve the system of linear equations, we actually want to eliminate one variable. We want to transfer two variables to one variable equation, right? So we can solve for x or y. So in this equation, we could observe first. We find we have x plus y and we also have x minus y. So by using the addition method, if we add the left side together, we realized we have 1 plus y and 1 minus y. Then the y will be eliminated. So we can keep x. So let's see. We add the left side together. So we will get x plus y plus x minus y. So that will be the left side, right? So remain the same if we add up the right side. So 7 plus 5. After that, we know we could eliminate y and only keep x term. So we will solve for x, and we realize x is equal to 6. So the basic idea is we try to remove one variable, only keep another one, right? Then we can solve for that. So in this case, we remove y variable. If we choose the substitution method, we use one variable to replace another variable. So in addition method, we just add them up, try to eliminate one variable. So let's check. If we know the value of x, we go back to any one of the equation. Then we can solve for y. So we put x equal to y to the first equation. So we have x plus y equals 7. When x is equal to 6, now in this equation we could use 6 to replace x. So we could easily solve for y. So after that, we will have our solution as 6, 1. This is our solution. Of course, we need to check our solution, right? How can we check the system? We need to check both of them. So first, we should check the first equation. Okay, we use 6 to replace x. Then use 1, replace y. So we check the left side is 7 and the right side is also 7. So it's true. It is still an equation. It's true. Then we also need to check another equation, number 2. We still do the same thing. Use 6 to replace x, and y should be 1. Then check the left side is 5. Right side is also 5. So this one remains true. After we check two equations, both equations, then we can conclude the solution is 6, 1. So this is the basic case of addition method. Sometimes we need to do a little bit more, then we can use the addition rule. Let's check another example. So this time we have this system. But when we observe these two equations, we realize if we add them up, we cannot directly eliminate one variable, right? Because we add them up, we will get negative 3y plus negative 3x plus 4y. So none of the variable has been eliminated. So we need to do something to help us try to remove one variable. We can observe if we could make the coefficient of one variable, coefficients of one variable. So for example, if we want to eliminate x, the first coefficient of x is negative 2, right? So if I can do something to make the coefficient of this x to be positive 2, then we add them up, we can get 0x because we could eliminate x. So how can we make negative 1 to be the 2? We only need 2 times negative 2, right? So for the second equation, if we times negative 2, we will have, we copy down the first one, but we times multiply by negative 2. So the first term we will get 2x, but don't forget you also need to multiply the remaining part. Negative 2 times 3y will get a negative 6y. Of course, you should do the same thing on the right side. So negative 2 times negative 4 will get positive 8. So after that, we could use the addition. We put the left side together. So this time we will have negative 2x plus y plus 2x minus 6y equals right side. We still need to add them up, so it's 10. After we do the addition, we realize this time we can eliminate x. Only keep the y term. Negative 5y equals 10. We will get y is equal to negative 2. So after we have one value for, we have the value for one variable, we can go back to any equation. Maybe this time we go back to the first equation. Negative 2x plus y equals 2. But this time we know y is equal to negative 2. So this time we keep x term, but use negative 2 to replace y. Then we can solve for x. X is equal to negative 2. So we know y, we know x. We have the solution -2, -2. Next step, we're going to check our solution. Go back to original equation 1 and equation 2. We write down it and check it. This is our first equation, right? And our second one will be minus x plus 3y equals -4. This will be second one. We use -2 to replace x. And y is also equal to -2. So let's see, -2 times -2 will get +4. +4 minus 2, we will get 2. Then we realize it's true. Left side is equal to right side. Let's check the second equation. So -x, -2, right? Plus 3 times y is also -2. So when you check your answer, make sure you be careful with the positive sign, negative sign, something like that. So -2, we will get to 2. And -6. So obviously, this is also true. Left side is equal to right side. So after we check the both equation, if both of them are true, which means this is our solution, is the solution for the system. Okay. All right. We can see another example. So you can pick one to eliminate. Sometimes we want to eliminate x to keep y. Sometimes we could just keep x to eliminate y. It doesn't matter. You can pick which one you think more convenient to you. You are comfortable with that. Okay, the basic idea is after we do the addition, we should eliminate one variable. So let's check this example. When we check these two, we realize if we directly use the addition, we still cannot remove one variable, right? We add them up, we will get 10x minus 5y. So we still have two variables. Our purpose is try to eliminate one. So we observe this time maybe we try to eliminate y. The coefficient here for y is -1, right? It's -1. And the second one is -4. So we want to, if we change the coefficient of the first y to be the +4, so +4 plus -4 will get to 0y. So that's how we can eliminate y. So we want to make -1 to be the +4. What should we do? Actually, we only need to multiply by -4. So -1 multiplied by -4, we will get a +4. So if we get +4, then we could eliminate the y because the coefficient of two y's are opposites, right? So let's do this. After we do the multiplication for equation 1, we will get times -4. So 2x, we will have -8x. 2x times 4, or -4. Then -y times -4, we will get +4y. But don't forget the right side, you also need to do the same thing. Okay? So -4 times 7, we will get -28. So we have this new equation. We copy down the second equation. After that, this time we realize we could add them up to eliminate. So we add the left side first. Negative 8x plus positive 8, we'll get 0x. And we check y plus 4y minus 4y, we will get 0y. And we add up the right side, we'll get negative 28. 0x, 0y, it's just 0, right? We will get this equation. 0 times x, it's just 0. 0 times anything, it's just 0. 0 times y, we also get 0. So left side, we only have 0. Right side, no, sorry, this should be negative 27, because 1 plus negative 28. Now we have this one. 0 is equal to negative 27. Is that true? Of course, this is not true. But this is what we get, right? If you get something, after you do the addition, you get something like me, the equation is not true, it's false statement, then we will get this conclusion. This system has no solution. Because we always get the false statement, then that means the system has no solution. Okay? This is a special case, right? Special case. Let's check another one. Let's check one more. Sometimes we will have the fraction as our coefficient. It's still the same. This time we have two equations. And we realize this time maybe we could try to eliminate y. Because when we observe the coefficient of two y's, the first equation we have negative half is the coefficient for y, right? And the second equation, we also have negative half as the coefficient for y. So it's just the same, but we want to make the coefficient to be opposites. So what can we make their coefficient to be opposites? Maybe we just need to change the negative 1/2 to be the positive 1/2 for the first one. What should we do? If we multiply by negative 1 for the equation, then we will get the positive 1/2 for the y, for the full coefficient of y. So let's try to do this. The whole equation multiplied by negative 1. So the left side, negative 1 times negative x, we will get positive x. Then negative 1 times negative 1/2 half y, we will get positive half y. But don't forget, after you multiply negative 1 on the left side, you should do the same thing. You always need to do both sides of the equation. So the right side, you also need to multiply by negative 1. This time we'll get negative 5/2. So after that, we copy down the second equation. We didn't do any change about the second equation, so we just copy down. After that, we could do the addition, right? We could do the addition of this. We only need to add the right side together. So we will have x plus half y plus x over 6 minus half y. And we also need to do the addition for the right side. So add them up is still negative 5/2. So we eliminate the y variable because the coefficient for this 2y is the opposites. So we only keep this. So we will have this So both sides times the reciprocal of the coefficient of x here. Why we should times the reciprocal of the coefficient of x? Because we times the reciprocal, we can make the coefficient of x to be 1. So we will get, we solve for x. Okay? We solve for x. Of course, after we solve for x, we only need to put the x, go back to the original one. Anyone will be okay. This time we'll pick the first one. Oh, okay. This is not the original one, but it's still okay if we pick this one. If you prefer to pick for the original one, is still okay. We copy down this. This time we already know the x value. X is negative 15. So remaining part, we only need to use negative 15 over 7 to replace x. So here, negative x, we will have positive 15 over 7, right? We get y. Copy the remaining part. So after that, maybe we will get half y is equal to, so this time maybe we need to get the common. So will be 14 over 30 minus 35. Yeah, 14. Half y will be equal to negative 14, 5. So y will be equal to negative 5 over 7. So we already know how to solve them, right? Solve for one variable. After that, we can list our solution. Next step, we still need to check. We copy down the equation. So the first equation we have is this one. Go back to the original one. And another one will be, this will be our second one. So for the first one, we use negative 15 over 7 to replace x. So negative x, we will get 15 over 7. Negative y, so we will plus 14 over 5. So let's check this one. We will get 14 over 30 plus 14 over 5. So we will get 14 over 35 over 14. So we find the common factor is 7. So divided by 7. So we will get, it's true, left side is equal to right side. Similarly, we still need to check the second equation, right? So this time we will have 6 over x over 6. So we will get 1 over 6 times, this is our x value. And negative y over 2, we will get positive 5 over 14. Let's check the left side. We will get negative 42. 15 over 42 plus 14 over 5 equals. So if we do a little bit, we will have this multiplied by 3, we will get, and obviously it's also true. Then we will conclude the solution is this ordered pair xy. Okay, so no matter we have the whole number as our coefficient or the fraction as our coefficient of variable, we can always use the addition rule. Okay, now let's summarize the method of addition rule. Okay, so basically we will say step 1 addition rule. We just want to summarize this. Addition rule. Step 1. First, we should make sure we use the standard form of the equation. If it's not standard form, first we should write our equation into the standard form. So which means x, y on left side and the number term on the right side. Okay. So step 2. We should do the multiplication for, if necessary. I would say if necessary. Maybe we should do the multiplication to, of course, we should multiply by a non-zero number. Multiply in a non-zero number to one of the equation. Why we should do the multiplication? Because if we multiply a non-zero number to one of the equations, so that the coefficient of one variable, because we have two equations, right? In each equation for one variable, for example, for variable y, we will have a coefficient. Second equation, we will also have y, we will have another coefficient. To make these two coefficients of the same variable can be opposites. If the coefficient of x, 2x, the coefficient of the first x and the second x to be the opposites, then we add them up, we can eliminate x. If the first y, we have a coefficient, and the second equation, we have another y. If their coefficients to be the opposites, then we add them up, we can eliminate y. So this is second step. And then step 3, we just do the addition. We just add them up. Okay, so if you want to do the multiplication to the equation, make sure you need to multiply the whole equation left side and the right side. If you want to add up two equations, make sure you should add up the left side and the right side. Okay, don't forget the right side. This is a common mistake. So after that, step 4, we're gonna solve, because we already eliminate one variable, we only keep another one. So we solve the variable we keep. If we eliminate y, then we solve for x, right? So step 5, after we solve one of the variable, we use the value of this variable to solve for another variable. By using the original equation, we could only pick one. Either one is correct. Okay, we just pick one equation, and if we already, from step 4, we already know the value of x, then we use that number to replace x. We could solve for y. Similarly, if we already know the value of y, we could use that number to replace y in the equation, then solve for x. So the last step is to check our answer. So check our answer in both equation. We could not just check one, right? We should check the first one and the second one. Okay, so that's all for the addition method to solve the system of linear equations.